All right, so when we're going to go ahead and we're going to graph a tangent function, one of the first things we're going to look at is we're going to find the period. The base period for tangent is 1 pi. So we look for a period. We're going to say period is 1 pi. And it's going to be divided by the number that's in front of theta. Well, the number in front of theta is a 1. So this tells us that the period is just 1 pi. Now in this graph, because of the way that I set it up, we'll notice that 1 pi represents 3 boxes. So if we look at this, we'd be like, all right, my period's going to start and end in 3 boxes, okay? Because each box is pi over 3. The next thing we're going to look for is we're going to look for the frequency. And the frequency is just the reciprocal of the period. So the frequency, if the period is 1 pi, will be 1 over pi. Just flip the fraction. Next thing we're going to look for is our phase shift. Call it the PS. The phase shift, what we do is we take what's inside of the parentheses and we set it equal to 0 and we solve for theta. So if we have theta plus 2 pi over 3 equals 0, it's pretty easy. We just subtract 2 pi over 3 and we get that our phase shift is negative 2 pi over 3. So what that represents is our starting point is going to be 2 boxes to the left. Okay. Now, when we're talking about tangents, our phase shift, which is our starting point, is an x-intercept. Okay. Now, granted, there could be a vertical translation out here, but how we started out is we started out as an x-intercept. So this is going to be an x-intercept right here. Okay. Now we know that our period is 3 boxes. So I go half the period to the right, which would be a box and a half, and I will have a vertical asymptote. Then I will go half the period to the left, which would be a box and a half, and I will do a vertical asymptote. Okay. Now we should know that tangent of x looks like, put this down here, looks like y equals x to the 3. So that helps me out because if I know that the graph looks like that, then I know that as I go to the right, I'm going to go up to 1. Okay, because tangent usually, as you go to the right, half the distance from the midpoint to the vertical asymptote, you're going to be up at 1. Now we're going to change that because this is a 4. Okay, so if we look at this, this is a box and a half. Half of a box and a half is 0.75 boxes. So we'll go over about to here. And usually we're up at 1. And I'm just going to put a dot there for a second. Okay. So what I'm graphing right now is I'm graphing this portion here. Okay. And then I go 0.75 of a box is here. And then I'll go down to here. Okay. Now, if we want to take into account the fact that there's 4 right here, what that does is that multiplies all the y values of the current coordinates that I have, and it multiplies them by 4. So this y value, this x-intercept, has a y value of 0, so that doesn't change. This y value has a y value of 1, so it jumps up to 4, because 1 times 4 is 4. This has a y value of negative 1. Negative 1 times 4 is negative 4. And then notice as I graph this, we're not touching our asymptotes. And we have nice curves right here.